The Winnipeg.net User Group 2016 season is brought to you by Aptius, IQ Metrics, Imaginet, Vision Critical, and Microsoft.
Okay, welcome here. Here is any opening words?
Yeah, welcome everybody. I want to thank all our sponsors, and without further ado,
Thanks.
Are you recording?
Yeah, I'm recording.
Awesome.
Okay, well, thanks for having me here. My name is Dawson Kroeker. I'm a software consultant for online business systems. As part of being a consultant, I get to see lots of different code bases and look at different pieces of code, different ways of doing things. A number of months ago, I had the opportunity of working with Mir on a project, and so that was a lot of fun, and it was also my first F# project. And F# is one of those languages that was on my list of things I want to do, or I want to look at, but never did. And so this was a great opportunity because I could start looking at it. So basically I fell in love with F# and really enjoyed writing code in it. But I also learned about a library called F FsCheck, and that's due to Amir because I was looking at some code or something that he wrote, and he just pointed out F FsCheck and said, what do you use for creating data in your unit tests? And he said, I've been using F FsCheck and it's really neat. So that was about it, but I dug into it a little bit more, and it turns out it enables something called property-based testing, and that's what I'd like to talk about a little bit today. So here's what we're going to look at. We're going to look at what property-based testing is. We'll do a little bit of an overview through some examples. We'll look at what F FsCheck is, what we're talking about when we talk about F FsCheck. We'll do a demo, and then depending on our time, we'll apply it to another problem and see where we come out with that. So property-based testing, what are we talking about? So a property is simply a characteristic or something about a piece of code that you want to test. And so all we're doing is we're asserting properties about code rather than asserting behavior in a specific example. So usually when we're writing unit tests these days, we're writing example-based tests. We say, if my input is this, then my output should be this. So a property is saying a more generic piece of information about that code. Maybe an example will help. This is my basement. I don't know if anyone has a basement that looks like this, but this is basically what I come home to every day. I've got 4 kids at home. I love them, but they do this to my house. And so let's just imagine, for the sake of this example, that I want them to clean up the basement, which is basically what I tell them every day, but still it remains. So let's just imagine that. If I was doing example-based questioning of them, let's say that they went and cleaned the basement, came back, and I wanted to quiz them and see if they actually cleaned up the basement the way I wanted them to. If I was doing example-based testing, I would say, did you put the yellow car in the cupboard? And you'll notice that there actually was a yellow car right by the puzzle. But anyway, let's just say, did you put the yellow car in the cupboard? So he would say yes or no. Then I might ask, did you hang the Spider-Man costume that was on the floor by the couch back on the wall on the 3rd hook? Did you pick up the brown Lego piece by the table and put it in the Lego box? So you can imagine, after I asked him these questions, he might have said yes to everything I asked him, to my kids, but I'm pretty sure the basement would look exactly like this afterwards. So this can be the problem with example-based testing. We're asking questions about our code for specific examples, specific inputs, and then verifying those outputs, but how do we know we covered everything? So if I was asking property-based questions for my basement, I might ask something a little bit more generic. Are all the toys picked up and put where they belong? Does the floor have anything on it besides furniture? Is the furniture in the right place? So these are more property-based questions. Now, you'll notice I don't have the picture of my clean basement with the property-based testing working because that's just not a reality. So, but maybe in your code you can get there with property-based testing. Okay, so we're going to take a little look at applying this to a piece of code. We're going to we're going to imagine that we need to write the modulo function. So you remember modulo is basically an operation that gives you the remainder. You divide one number from another and take the remainder of that operation. So we're going to look at some example-based questions we might ask about that, example-based tests, and then we'll look at some property-based tests. Okay, now, opening slide of F#. Who here has worked with F# before? Okay, so we have a few people that are a little bit familiar with the syntax. I'll just walk you through a few things that you can pay attention to here if you're coming from a C#, C++, or JavaScript, or wherever we're coming from. I said C++, but really that was only my life about 5 years ago, and not too many live there anymore. But let's look at what we're talking about for F#. So the open statements are just using statements in C#. This is an attribute. You can see the only difference is the angle bracket. And the next line is a function, believe it or not. The name of the function is 10 mod 5 should equal 0. And what we're doing here is something fancy in F#. You can use these double backticks and put that around any string you want, and that now becomes, it can be a variable name, a function name, it's a literal. So you can use that for whatever you want. So what we're looking at here is the name of a function, any arguments that function takes, and they are usually separated by spaces, not commas. The equal sign, and then the next line is going to give us the body of that function, and it's going to be indented instead of using curly braces. So if we have any questions about F# or what you're seeing on the screen, just pop up your hand and I'd be happy to explain what we're looking at. Okay, so example-based testing, we're saying 10 mod 5 should equal 0. So if we wrote this test, we might go and write a function that's going to make this pass. Done. Right? Mod m of n. If we just set it to 0, this test is going to pass no problem. Okay, great. So obviously that's not going to cover all the cases that we want to cover with modulo. So we give it another one. We say mod 20 mod 3 should equal 2. Well, F#, we can just match those particular inputs and say, okay, if you have 20 and 3, the result is 2. Everything else, the result is 0. So now we're passing both of those tests. Okay, well, we'll be a little more clever. We'll throw a crazy number at it and say it should equal 18. Well, easy enough to just pop in the crazy number into our pattern matching and give the correct result. So you can see when you're doing example-based testing, you never really know if depending on what domain you're in, but you can get into a situation where you never know if you have full test coverage of all the different scenarios. Okay, so we're gonna look at this from a property-based perspective. So let's try to think of some properties of modulo. So here's the first one I thought of. A mod n. A mod n will equal 0 whenever n is 1. So all we're saying is you have a number, you divide it by 1, what's the remainder? 0. So that's always true. So that's a property we can test and check if that's always going to hold true. Okay, here's another one. A mod n will always give you a number that is less than the absolute value of n. So if I take 10 mod 3, the answer is going to be 3 is 9, so remainder 1, right? So 1 is going to be less than what n was in this case. N was 3. So there's another property. Turns out there's a bunch more of these types of properties, and I just pulled up Wikipedia, looked up the modulo operation to look at what we're talking about. And we're not here for math tonight. Maybe there's some math people here, but here's a few more properties that we can see of mod. Okay, so if we take a mod n and then we do mod n again, it will keep the same result. N to the x, mod n is still 0 whenever x is greater than 0. We have the inverse. I'm just going to flip through these. There's the distributive property. So these are all different properties of the modulo operation. There's one more distributive property. So what we can do is we can pop these into a unit test, and now we are testing all these different properties about it without actually giving it example-based inputs. So how are we going to do that? Well, this is where FsCheck comes in very handy. So you could just write a for loop and loop through a ton of numbers and test them out. And that's a valid scenario. But FsCheck is going to give you random input data into your function and verify your property with that random input data. It's very easy to get a hold of. You can just grab the NuGet package. Depending on what unit testing library you're using, if you're using NUnit, XUnit, there's a specific package for you. I'm using XUnit here because it adds a little bit of some just syntax candy. It looks nice. So that's why I use XUnit. Features of FsCheck. So it's going to assert your property multiple times with random data. So each time you give it a property that you want to test, it's going to run it through 100 different times with different pieces of random data. And so that's one way that it verifies that your property always holds true. But you can imagine with all that kind of random input, you're going to have some crazy long numbers that are going to be very hard for you to debug with when you actually want to figure out why your test is breaking. So it does automatic input shrinking. So it finds a failure, and then it's going to play with that number until it finds the smallest possible input for your property that's going to fail the test. That way it's easier to debug with. It does conditional properties. It can classify your test cases. It gives you the ability to have custom input generators. You can use it in F# or C# if you want to. It's a .NET language, but there is a C# wrapper for it too to give you C# syntax. Okay, so let's look at some code.
Can it handle scenarios where it's like objects coming in rather than numbers or primitives?
Yeah, there is a way of managing the state of an object.
How does it generate random objects?
You have to teach it.
That's where the custom generator stuff comes in. So you got to tell it how to construct random instances of that
You have to give it guidelines.
Yeah, you can
Right.
teach it. If you have a custom type, you can build a generator for that particular type. And if it looks at the properties of your type and it sees that it has an int string, it knows how to build those. So it can just build up those particular properties of your class for you.
Or you can say it's an email.
Yeah, usually.
And teach it how to generate valid emails. And
Yeah,
it will
but
create one of those automatically for you.
I'm just thinking, and again, I'm coming from C#, not a functional world. But the objects are usually part of an object graph. As soon as I have an object, it's usually not an object with 2 ints in a string. It's an object with 2 ints in a string and 2 other objects in a collection of some other class, and those classes have other classes.
You can
Yeah.
teach it how to generate everything.
Okay.
You can decide also, you can say things like, here's how you create valid instances, and here's how you can create invalid, or whatever category you want. So, because usually in our tests, we don't always want the same, right? Because of all the possible instances, probably you want to test a few of these, a few of here, a few of here. So you can teach it and say, I want to generate these. And it realizes what you want, that's pattern matching, and goes and generate that for you.
Okay, so here's those example tests that I was showing you before. We have our modulo function here that does everything with simple pattern matching. But we'd like to go ahead and do this the property testing way. So let's give this a whirl. This mouse is gonna cause some problems. Okay, so our first property was that modulo 1 always returns 0. So we can write our property like this, and you'll notice I'm pulling in a few different libraries here. We have FsCheck and FsXUnit, FsCheck XUnit. That's going to give me this property attribute right here, and this property attribute inherits from fact if you've used XUnit before, but it's kind of like the test attribute you would put on your test. So that's labeling this particular test as a property that FsCheck is going to run for you. And then it's going to return a true or a Boolean value. The last line in a function, whatever the last line in an F# function returns is the return value of that function. So this function is going to return true or false based on whether the result was 0. Now I'm using I here for my numbers, and that's because I'm using big integers. Just to some of the properties that we'll get into in a minute, we're throwing big numbers at it, and they work better with large integers. So let's write our function here. There's our modulo with the big ints, but again, we're just starting with our very simple solution, which is just returning 0. So for this particular property, this is going to hold true. So we can look at the test results. Modulo 1 always returns 0, pass. If we look at the output, we can see it actually passed 100 tests. So what's happening there is it's choosing 100 different pieces of random input into my function. The function is this property. Modulo 1 always returns 0. So if we want, we can actually run this in the F# interactive. So let's just start this guy over, and we'll get our references sent down there.
I think there's a C# interactive right now.
I saw something using that.
Yeah. Only because it has Roslyn.
Sorry?
Because of Roslyn. Huh?
You don't want to go there.
Okay, so we can try running this function. Modulo 5, 10, 4. Oh, right, we're using big ints, so need to use the i's. So the result is 0, even though it shouldn't be, right? But let's check what FsCheck is doing. We can move this function down into our interactive window. So now we have a function called modulo 1 always returns 0. And so I can call this function with a number, and it will, it will do 10 mod 1, and it will return true or false if it returns 0. So this is where we can use FsCheck. We can say check quick, and we'll give it that property. So this is what the unit test is doing behind the scenes, is it's running this property 100 times, just like what's going to happen here. So we can say, okay, it passed 100 tests. Great. What was it actually doing? We can look at the verbose option. So now we're actually seeing the input that was passed into my function here. So these are all the numbers that we're seeing. La 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 la. There's 100 of them. Great. So let's keep going. We have a passing test. So the next property we were looking at was a mod n is always less than n, or the absolute value of n. So now we have two variables in play, right? We have the a and we have n. So we're going to be passing those in, and those will both be random integers. We're going to do our modulo operation, an, and then assert that it is less than the absolute value of n. Great, let's try it out. Fail. Okay, so now we can see why are we failing. I'll try to expand this a bit. Can everyone see this okay, by the way? Okay, good. Okay, it's telling me that it was falsifiable. So the property that I'm defining has been falsified after 4 tests. It shrunk it down, so you can see the original test that failed, and then it played with it a little bit to try to get a smaller value that also fails. It turns out both 0 and 0 cause it to fail. So those 2 numbers are what is passing into my modulo function. So you can imagine A is 0 and N is 0. So mod 0 of 0 is less than 0 because N is 0. So that's why we're failing. So we could say, well, fine. We can just do, where are we at here? N minus 1. That should solve that.
Anyone else find it weird that it says 1 millisecond runtime, but it takes a little bit longer than that build time?
Yeah, build. Okay, so that passes. Let's go with something. What's next? Okay, so one of the next functions was the identity function, and so we can just plug this. This is basically straight out of Wikipedia, right? It's the definition for modulo, so or the identity definition for modulo. So we take mod A of n, and then we take that and go mod n as well, and that should be the same as mod A of n. So let's try that guy out. We're good. Okay. Maybe we found a really easy way to implement modulo. Let's give it something else to play with. Now, did I miss one? No. Now, the interesting thing with this guy is, you remember the definition was n to the power of x mod n should equal 0 whenever x is greater than 0. Okay, so we can put the n to the power of x mod n part in, no problem. Power to the n is that function right there. We're going taking n to the power of x, taking the modulo to modulo n, and that should be 0. But how do we do the x is greater than 0 part? Because you remember our random input is giving us the full stream of integers, so we're getting negative integers and everything. This is a conditional property. We're giving the condition on the left-hand side of this operator, and we're saying x must be greater than 0, and then we're going to give it an operation on the right-hand side that it's going to run whenever x is greater than 0. Basically, all it's doing is filtering down the input. Now, if you gave it an impossible piece of input, it would fail the test just because it ran out of data. So, you know, I don't know. We can try this guy. If we set it to, oh, right, wrong language. It depends on how many times our random number generator is actually going to choose 1. So how do we pass here? No, actually, I guess it figured that out. But you can come up with a situation where it's going to run out of valid input, and then it will just fail the test. So what are we seeing here? We are seeing we have a case where this is failing. Thanks, guys. If we made that pass, that would be an interesting definition of mod. Yeah. Okay. We have a problem. Oh, no, not yet. We do have a problem. 0 and 1 aren't working. So at this point, let's just give in and give it the normal definition of mod that we're familiar with. Great, that should solve it. So I'll just do a build. Now we've got mod. We know that that mod should work. Is this going to pass? Oh man, now we broke everything. What's going on? Did we define our properties wrong? Well, divide by 0 exception. And the reason is we never filtered any of our other tests for bad input. And there's only one bad input when it comes to modulo, and that's 0. So if you're doing something mod 0, it's kind of like dividing by 0 because you're checking the remainder after the division. So that's the problem that we're having here is all these tests are passing in 0. We're getting modulo and a divide by 0 exception. So let's fix them up. We can add that conditional in again. Nope, wrong one. How many do I have to go here? There we go. Okay, so we're saying anything is fine here as long as n is not 0. We're going to have to put brackets around this so it knows that that's a single operation. Okay, and this guy already has the conditional in there, so let's just add that. We'll build things up here again and see where we're at. Still, oh, wrong one. So it's still using 0. What am I missing? Did it not build? Oh, we're still getting a divide by 0 exception. What's the problem? Well, the conditional operator in FsCheck is not lazy in that it's going to evaluate both sides of this expression regardless of whether the left-hand side holds true or not. So that means we're still doing this divide by 0. So there's a trick we can use to get around this. All we have to do is add the lazy keyword to the right-hand side. And now we're going to actually wait to evaluate the condition on the left-hand side before we evaluate the condition on the right-hand side. So let me just pop that in there and then we should be good to go. So that should solve those problems. So we got a couple more properties here. Let's try popping those in.
Just change the thought process for TDD a bit, right? Because normally when I TDD stuff, I just make it work for the one sample input, and then I add more input-output scenarios to expand the complexity. Here, I'm kind of expanding the complexity in a different way.
Yeah, your properties are going to move you to implement it in definitely in a different way. And I think you still can do like a TDD approach, but you might need a fuller implementation to get to where one of your properties is taking you.
I don't know. It's a great, actually, question. In TDD, when you find, remember when you put a property and it passed, right?
Yeah.
Without changing code. Sometimes in TDD, you would say that's a smell, right? What do you guys think? Is it a smell or not? Sorry for disturbing slumber.
When I had a new test, I expect it to fail. I wouldn't necessarily say it's a smell, but it would be a surprise.
It would be a surprise.
Right? I wouldn't have added that test if I expected it to pass, because it wouldn't help me evolve my solution.
True, but how easy is to find failing tests without looking at the implementation? How easy is for you guys?
You just hit run test.
Sorry?
You just hit run test. Or you mean
no,
write
to find, yeah,
to write new ones.
What to write. For me, it's not easy. I need to think for a while to find an example that fails. And to be honest, what I'm thinking is about this. What properties I'm looking to test. So from my point of view, TDD and properties testing, they share the same idea. The difference is that we learn TDD by example. But let's imagine that we don't know TDD, and Dawson comes the first day and says, here's how we do TDD. We think of the properties, and we would have given a second thought, right? And we all would work this way.
Yeah.
And this is much easier than try to discover scenarios that don't work.
The idea behind TDD is that you're expressing the intent.
Exactly.
So property lends itself pretty well.
Exactly. We naturally don't realize it, but when we think of TDD, we think of the property, and then we come with one example. And then we come with another example. And more often than not, we don't generalize and say, look, this is a property. I'm going to call it a property and put with double quotes, this is the property and all the examples. But we do this naturally for TDD. I don't think it's different at all. Yeah?
The numerics thing, right? Numerics library. Like, if I put in square root of 2 to square root of 2 and then come out 0, or will it just bug out?
You asking if? I'm not sure about the question.
It uses numerics library, right? Numerics library, it's pretty good with object handling. I noticed that you can put irrationals in there, and they use them pretty good.
Yeah.
The way they're supposed to be used. If you chucked in 2 irrationals, will it work?
I think so, but
I'm not sure. I don't think I'm using any special, like this is basically just on top of .NET. So I don't know if there's special handling for numerics. There probably is a library that, like an F#, because working with numbers is very common in F#. So probably, I don't know if I just punched a rational number in here, what would happen.
But the whole idea is you're not punching in numbers and examples, you're punching in rules, right?
Yeah, and we're letting FsCheck punch those numbers in for us, given the type that we're giving it. Okay, so interesting thing while I was coming up with these properties, I put the identity rule in here, I put the distributive properties down here. I got a failing test, and this is a failing test with like the compiler modulo, right? Like the built-in modulo. I thought, okay, did I write something wrong? Is my test totally broken? But it turns out with modulo, you actually can get different results, or you can get a negative number in some situations. So if you do 10 mod 3, oh wow, okay, so 10 mod 3 is 1, but negative 10 mod 3 is negative 1. So it's giving you the result, but it can be on either side of the of 0, I guess. And so what you're doing to get the result, it's valid either side of 0, basically is what we're saying. And so if you look at this distributive one, this is what it's catching, is that the left-hand side of the equal sign here is negative and the right-hand side is positive, even though they're equivalent when it comes to modulo. So we can address that and make our new and better modulo. Oh, where are we at here? There we go. Okay, so all we're doing here is we're doing a match on the built-in modulo, and we're saying when the result of that is less than 0, all we're doing is taking the n value and adding that to x, and that's the equivalent value of that modulo. So we're fixing .NET, I guess. Depends on how you look at it. It's not right or wrong, but it's causing our test to pass, which I thought was interesting that actually brought that up. So now we're passing. Go figure. So that's property or FsCheck in a nutshell so far. There's lots more that we're going to look at in a minute, but before I go on, are there any any questions about what we've seen? Any property-based tests you have for me? Yeah.
So what I would like to see is this applied in a more complicated situation. I love what you guys are talking about, saying about TDD and how we normally think about property-based testing. I agree a lot with that. I would like us to, if possible, maybe not now, maybe in the future, go through an example with real code or with more complicated code and how we would use property-based testing.
Yeah.
Yep. And I do have one more example we'll look at. It gets a little bit more complicated, and then we can just play around with some stuff at the end if you want. Look at some other options. But there definitely is ways of generating this kind of code, these kind of numbers.
So good question. How many scenarios or property tests do you end up with when you're working with more complicated method, for example?
As many as you need.
So that's
as many as you feel confident. When you feel confident, stop.
Yeah, cost quality, right? And you can write tests all day and make the code pass. It's great when you have budgets. You have time to
But it's about quality, like you said. So when you're confident that you have tested enough, then you stop. If you keep going, it's because you think you have a bug, right? That there's scenarios that you haven't tested, so you keep going. But that's the same thing with TDD. The difference is with TDD, we say, screw it. I don't want to write more examples. It's good enough. So all my tests pass.
Well, TDD is very helpful in that regard because you stop when you can't think of a way to write a failing test.
Or when you're tired of writing examples.
Well, yeah, but usually TDD, you don't write examples that you know are going to pass. I don't, at least.
You write one.
I write one, I make it pass, and then I write another test that I expect to fail, and then I make it pass. And eventually, I'm going to get to the point where I can't think of any more tests that I can write that would fail, meaning I'm done that piece of code.
But that's the danger, right? Because we wrote one, we wrote two, we wrote three. When you reach the 10th, you don't want to write code anymore. And probably that convinces you that this is enough. This is a great coverage.
Well, it's not that I don't want to write code anymore, it's that I can't think of any scenarios that I haven't covered.
You can think, because you haven't tested all the possible values. Of course you can think. You just,
yeah, but
it's not convenient to write.
What I'm trying to say is when I write the next test, I don't just pick a new random value. I pick a value that I believe I haven't implemented the implementation for yet.
But that's the problem. You're looking at implementation too much.
So I think there's two different ways of looking at it. Where property-based testing is going to be really helpful is where your input size is unmanageable or infinite, or like integers, for instance, just keeps going. Maybe not on a computer, but it is infinite. If you're talking about a closed problem space where you have like 5 to 10 different inputs, just write all of them. Write all the tests. Problem solved. Like, it may still be helpful to think of it as properties, and that might get you to the same place. But I think where property-based testing is really going to help is where you have this kind of situation where your input size is unmanageable, where you actually can't spend enough time coding or it will be unmanageable to write all of those tests. So, integers, strings, all these things have a lot of different inputs. So I think that's where it starts to make a lot of sense.
So how does this differ from using some kind of a library that just automatically generates random data for you, and then you're testing that your output is the same? It almost kind of looks like these properties are just a bunch more operators of examples.
Yeah, and that's at its core, that's what FsCheck is doing for you, is doing that kind of random generator. So you might use auto fixture or something to do a similar thing, right, where you generate some random data. But where auto fixture or something similar is different is that it's just generating it for you once. Where FsCheck has built in, I'm going to test this 100 times, or you can probably change it to a lot more times, where it's verifying that anything it throws at your function, it still comes out that this property holds true. And you could do that with auto fixture, write a loop or whatever. But this has a nice way of handling it, and it also gives you the input shrinking and a couple other features around
The
that.
shrinking algorithm plus the idea of distributions. If you want combining generators, if you say, I know that from my customers, usually 80% are valid and 20% invalid. You can ask FsCheck to generate that distribution for you. And that
Dude, you're stealing my thunder.
Huh? Sorry. I'm not sure. Maybe you can, maybe you can. Let's ask.
Question.
So just to add on to that, I think if you were to do the regular TDD process of writing and putting in values and say, I expect this output, you can't use a random generator because you want to control the input and you know the output. When you're generating numbers randomly, you have to already know the answer, which means you have to have a working function to run against those numbers to get the output that you expect. So you're not really testing, are you?
I mean, I can totally see this. We work with TDD. I think it's a different mindset. Not better or worse, maybe actually better. Right? Because instead of coming up with, so the way I said I did TDD, right, an example, input and output, fails, make it pass, come up with another one that I think will fail, keep going until I can't think of any more that would fail. With this, instead of coming up with a sample input output, I'm just going to come up with a sample of rule, a property, make it pass. And then I may say, oh, I know that I haven't handled negative numbers properly yet. Instead of coming up with an example input with a negative number, I'll come up with a property. What do I expect to happen with negative numbers? Right, and then let it run on 100 different. So I can totally see I could TDD with this.
Yeah.
It's just a different mindset.
Yeah.
But do you end up, this was my experience trying this, but implementing repeating the implementation in your tests.
And that's one of the things you're trying to get away from, and is repeating the implementation in your tests. So that's the hard problem when you're talking about creating property-driven tests, is how do I not just recreate the implementation? And funny you should mention that, because we're going to look at how can you find properties. What kind of questions are you going to ask to come up with these? So yeah, you can create the expected solution and then compare, but then are you really testing anything? So there's this great website, F# for Fun and Profit. You should probably check it out if you're interested at all in F#. But he has this great post on how to find these properties. And so here they are. Start with different paths, same destination. You can go down different roads sometimes to get to the same destination for your code. So if you can do that, then you run the test that you are, the system under test, I guess, and then you go down a different path, compare your outputs at the end. So this works with something like add, where you're, add 1 plus 3 is the same as add plus 1, add plus 2. So you can get to the same result. Now you're checking a property about your add function. There and back again. So you think about serialization, deserialization. If you serialize something, deserialize, you should get back to where you started. These are basically just questions you can ask against your code that you're trying to test. They're not going to all have answers for your particular piece of code, but they're good ways of coming up with this list of properties that you can actually write tests for. Some things never change. So maybe a property holds true for your piece of code all the time. You have a sorted list, and it should always keep things sorted. So no matter what you add to your list, it's always sorted. So that's a property that never changes. Idempotence. So you do an operation on your code, and then you do it again, and you do it again, and it should never change the result of that piece of code. Solve a smaller problem first. So if you can break down your piece of code into smaller problems and prove that it happens for a smaller problem, then depending on your code, but it should also hold true for the larger set. Hard to prove, easy to verify. Thinking of like NP complete problems here, or if you think about a maze and you have one solution to a maze, it's easy to verify that you got from here to here without hitting a wall. But it's hard to it might be hard to actually get there. So if you can verify that you solved the problem, then that would be a good property to test. And the test oracle. So this is similar to what we were talking about, but where you have an answer that you believe to be true, and you have a new implementation of how you get that answer, you could compare those values. So this might be similar to where you're actually putting your implementation in the test, but this is different in that you actually have a source of truth that you know to be true, and then you're writing maybe an improved algorithm, or you're trying to do improved performance or something, and so you have this test oracle. Okay, so those are the questions that you can ask to help you come up with these properties. So let's try them out. We're going to look at using using Roman numerals. Now I've written up a sample solution here for converting Roman numerals to Arabic digits. So we've got 2 is taking a Roman numeral. We've got all the values for the Roman numerals. And all we're doing is we're getting all of those values. We're taking our number. We're replacing all of the shorthand with the non-shorthand version. So you remember with Roman numerals, you can have the I5, which is the same as 4 I's. Turns out it's a lot simpler to process this if you just get rid of all of those shorthands. So I'm just replacing all of them with the values. And then all I have to do is go through and sum up, map them to their values and sum up the values. So also have a backward, like getting back to the original number, 2 Roman numeral. All the solution here is we're taking our number, replicating it whatever that time is. So we have 1 I replicated this many times, and then just doing replacements. So if you have 5 I's, that's a V, 2 V's, that's an X, blah, 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 all the way down. Okay, so we're gonna start thinking about these properties. So if we go back to our list, we'll pop up to the top. Different paths, same destination. Can we do this with Roman numerals? So we're thinking about going, we want to get, now let's see here. Okay, we're going to test the 2 Roman numeral function. And can we get to the result, the same result in 2 different ways? And it turns out you can. What we could do is split up the number by digit, get the Roman numeral for that particular digit, and then just put them all back together again. So, and then we can also get the Roman numeral for that entire number at once. So have a quick function here that's actually going to get the number at a particular digit. I'll just pop this into F#. Oh, right. I'll have to. So if I take a number 1, 2, 3, 4, 5, and I pop it into number at, oh, should have put it the other way. That's okay. So we'll try to get the first digit, and this is going right to left because that's what we mean in this case. So the first digit is the 5. If we're getting the second digit is the 4, 3. So you can see this guy is just a little helper to get the different digits. So we get the number at the 1 place, and we're gonna move that to Roman numerals. We'll do that through the tens, hundreds, thousands. We'll get each of those Roman numerals, and then we'll just pop them all back together. So if we build this.
Good question.
Yep.
So the last number at, for position 3, return 15, right?
Yeah, you're right. And I realized that I did this 2 different ways as I was typing. So I actually meant I should have put in 10 for the next one, because what I am getting is the full value of that particular place. So the 4 it represents 40. At the hundreds place, it represents 300. So my bad. I did 2 implementations on that and was not paying attention. So, and the thousands then is 2,000. Okay, so that didn't work. Why not? Let's check. The input must be non-negative. And has anyone ever represented a negative number with Roman numerals? So here's the problem. We need to reduce our input basically to the valid number of Roman numerals. Basically, we have from 1 to 3,999 that we can represent using Roman numerals. So we could do this like we did before. Remember, we had that, that operator that filtered things out for us. I'm going to show you another way of doing this. It's a way of giving us a generator for that particular number. Okay, I'm going to create a new type called Roman numeral types. All it's going to have is a member. This is like a property. And we're going to use some FsCheck magic here. We're creating a generator from a list. So we give it elements. We're going from 1 to 3,999. That's the range we're talking about. And then we're going to pipe that into arb.fromGen. So basically we're taking our generator and making an arbitrary number creator. What in FsCheck an arbitrary is basically a generate or a way that you get a number out of its random number generator system or its random data creator. So we are defining here a way to create a valid Roman numeral integer. Now, how are we going to tell our property to use that? And you can do it like this by modifying your attribute. We're saying the arbitrary on that property uses type of Roman numeral types. So we just give it that class, and now because this valid integer returns an int and our property also needs an int, it's going to use this generator to pipe in that number. So if I build, we should be reducing. We're going to be going through this generator. We're going to use this list of items from 1 to 3,999, and you can see now our problem went away. So now this is a little bit ugly writing this property every time, so we can make it a bit prettier. Wrong one. So we're basically just making our own property here. It's inheriting the property attribute, doing exactly what we saw there before. But now what this gives us is the ability to use this new Roman numeral property. Just a little bit prettier. Okay, so that was there and back again. Nope, that was different paths, same destination. So let's try there and back again. And so the obvious thing is here we have a number, we're going to take it to Roman numerals and then back to numbers. Oh, keep doing that. So a really simple test here, all we're doing is we're getting our number, we're putting it through the to Roman numeral generator, we're passing it back through the to integer, and then we're saying that the result should be whatever we had passed in. So that passes, great. We're using the same input generator as we did before because we have this property on there, Roman numeral property. Okay, we also want to just assert that we're always using valid characters. So in this case, I'm not really following a TDD approach, and simply just to show you how these properties, how we can come up with those properties. So you would want to follow a more TDD approach when you're doing this, writing the properties as you go. But here's another one we can say, always uses valid characters. And this isn't the there and back again anymore. Now we're talking about some things never change. So this would be a property that never changes about Roman numerals. So whenever we call to Roman numeral, it always uses the valid integers. What else could we say? Okay, we could say 1,000 is represented by M. And so we need to check how many M's we should have for a particular number. So the expected number of M's is going to be our number divided by 1,000. And then we'll take the result and we'll take the first letter while it's M, get the length of that to check how many M's there are at the beginning of our Roman numeral, and make sure that the number of M's is what we expect. Now here's what Amir was talking about, where you can classify the different types of situations you are in. So I'm going to be writing this test, take a number, convert it to Roman numerals, and then verifying that it has the correct number of M's. But I'm also going to be testing which numbers, how many M's did I have? So maybe I had 0, where the number was less than 1,000, so we don't need any M's. Maybe we have 1, 2, 3. And it's going to show us in the output what kind of distribution we have. And that can be helpful for making sure that your input set is what you actually want to be testing. So if we pull up the output, you can see we have less than 1,000, 30% of our values are less than 1,000. And then we have different distribution on the different number of M's. Now this isn't exactly what we want, because we're specifically testing the M's. So how could we reduce our input size to values that are greater than 1,000? So let's go back up here and work on our generators. Gotta keep track of these better. Okay. We're going to make a new type, and we're just going to call it thousands. This is a distributed, help me out here, discriminated union. There we go. Basically, we're making a new type name called thousands, and it holds an integer, but it's strongly typed. We can't assign an int directly to it, or we can't get it int directly out, but we are going to basically write a casting operation that's going to take the thousands operator and pull out the integer. So what we can do is pop this into our types here, and we can say if we specifically want thousands, now we're just going to generate the numbers between 1,000 and 3,099. So we can define a new type that's only going to return us those particular values. So we can use this and we can just put that type on the number so that it knows that we want a thousands number. And now when we build this, did that take? We can look at our output. No, it must still be the old one. Take a look at the output now, and we don't have any particular case where we didn't have any M's. So we're only using from 1,000 to 3,999.
Hey, Dawson.
Yeah.
I'm really struggling to picture how. I'm trying to think through some real world business app scenarios I've done and how I come up with properties for them. And I'm really struggling to translate the samples you're showing here to kind of like business app scenarios. Can I give you a simple scenario and you try to help identify what properties might be?
Let's try it. Let's try it.
It's going to be like a 5-minute divergence, so I don't want to interrupt you.
No, let's do it. We're basically at the end of this demo, so let's just
okay.
Let's
I'm
do
trying
it.
to think of a scenario, something that my team was working on the other day. So we're doing a healthcare app, and somebody is searching for a specialist to refer a patient to.
Okay.
So I think it's C#. This is C#. So maybe we've got a class that contains a collection of specialists, right? And when we search, we pass in a patient object. And what's really important is the order of the results. I want to see the specialist closest to me first. But there's a business rule. Some specialists are preferred and some are not. So preferred should come first. So let's say I have 2 specialists that are very close to me that are not preferred. and one that's farther away that is preferred. Okay?
Okay.
So if the farther away one is less than 30 kilometers, it should show first. If it's more than 30 kilometers, it should show after the non-preferred close ones. Okay, so that's a business rule that I want to test.
Right.
So I got some logic. I got a class and search, I pass in a patient with my address, it gives me the 3 providers returned, and based on the distance from me and preferred or not preferred, it has a certain sort order.
Right.
Okay? So what would properties be for that? I imagine today, if I was to test that, I might have some class, maybe let's call it a health system, they call it a system of doctors. Health system class that has a collection of specialists, and it has a search method that takes a patient object. In my test, I'm going to new up 3 specialists, 2 non-preferred that are close, and 1 preferred that's farther away. Health system.add, blah, blah, blah. New up a patient object, pass it in, and I'm going to say for this test setup, the 2 non-preferred that are close and 1 that's 20K away, the preferred should show first. Test number 2, 2 non-preferred that are close, and a preferred that's really far away. Preferred should show last.
Right.
That's what I would do in kind of example-based testing.
Right. Yeah.
So what could properties be for something like that?
Okay. Well, let's pop back to this guy. This is the first one that pops out to me. Some things never change. So in your results, the first property that I'm thinking of, just hearing the problem, the problem you're talking about, is that a preferred provider, is it?
Specialist provider, same thing.
A preferred specialist should never be after a unpreferred specialist.
Unless the preferred is really far away. Let's say 30K is the threshold.
Okay.
Right, so I got 2 non-preferred that are really close.
Yeah.
And a preferred that's 29K away. So send me to the preferred. If
Okay.
the preferred is 31K away, don't send me to that.
Right. Okay. So there's a threshold.
There's a threshold, and that's the
Yeah.
business logic I want to test.
Right. So I think that's your property is preferred specialists are returned first unless too far away.
Yeah.
And
So I don't understand how you would express that property without redoing the implementation of my test.
You limit your input on different tests, and you're testing different scenarios.
You limit my input on different tests.
You have multiple tests,
Okay.
obviously. And certain tests are going to have different limitations, such as I'm going to generate different distances for a specialist, and for this test, they're all going to be less than 30, so that you get a certain scenario. And then another test, some of them are going to be greater. Stuff like that. So it's those limitations you're putting on the input. You do that for different tests so that you get your different scenarios. So ultimately, it all ends up being very similar to the kind of tests that we're all doing here. It's just that you're going to end up with more random.
So the 2 examples I would have
sounds
done.
like you're not really wanting to limit your input unless the input's invalid, though. It sounds like you're more defining the different properties that your output should be associated by. So it'd be more like a valid situation is going to be if this and that, then it should be this.
Your list will look like a set of preferred that are close, non-preferred, preferred that are something like that, right? The same way that doesn't show how you can create the numbers that are greater than 1,000. You can have a test that receives those sets, right? And say,
Okay, so
if I give you all these in any order, I will get the sets in this order. So you're not talking implementation.
Okay.
You're just saying, I have 4 sets because your list, from what I heard, I think it's like in 4 sections, it will be separated in 4 sections. So I have these 4 sets, I put them all together, I randomize them, I give them to you, and you will have to give me the same that I got before. These 4 sets in this order.
Right, so whereas by the old way, I would have done like a test that's 29K away and a test that's 31K away. Right?
Not only that, you would have done it with 1, with 2,
yeah, so that's the old
maybe
way.
with 3,
so the new
maybe
way,
with 10.
Right, so just to make sure I understand, so the new way, the property-based way would be define, generate some sample data between 0 and 29, a bunch of them, and then another test that generates between 31 and up, a bunch of them. And those are my 2.
Yeah, you actually would say a list. You don't care how many they are. FsCheck takes care of that.
Right, but
if
I'm
you say I
defining
want a list, sorry?
I'm defining the bounds of the values.
No, you don't need to. You can.
well, you would
need to, right?
want to define it as far as like valid inputs, I think, right? Like you have some sort of range. Like, there's not going to be 16 trillion kilometers or something, right?
Well, the inputs in the current world, right? The inputs to the test is here's a list of sample specialists, each one with an address or something, let's say.
Yeah.
And here's the patient here with an address. And based on that, that's the list and the list of specialist addresses and patient addresses. It's going to give me some result. I'm going to have specific testing data in each of my test cases with different scenarios.
So part of the logic is figuring out how far they are.
Yeah. Well, why don't we why don't we put this on pause? Let him finish.
Yeah. Okay.
And then if everybody wants to, welcome to stay and keep talking about this.
All right. Well, we looked at the demo. Just to review what we looked at what property-based testing is. We're defining characteristics about our code rather than example-based testing. And so you can use FsCheck to generate random data to pipe into your code and test that your property holds true, whatever input you give it. And we looked at a couple of different examples of how you could do that. I'd highly recommend you check these out. F# for Fun and Profit, I already mentioned. Mark Seaman does this Diamond Kata with FsCheck, and it's basically talking about property-based testing, but he does a much better job at it, so I'd highly recommend you check that one out. He also has a Pluralsight course that you can look at, which is basically coming out of his blog, that one. So I'd highly recommend you take a look at that. And I mean, that is the end of my presentation. So we can keep chatting about this if we want, or we can...
So we can leave whoever wants to go. I just want to thank Dawson. That was a great presentation. And next